Welcome, everyone. Today we're going to dive into the architecture of behavior and explore why the post-training recipe, rather than the model family, is what truly drives multi-agent LLM diversity. As you can see in this schematic, the core behavioral engine, the post-training recipe, accounts for a massive 70% of diversity, whereas the model family is merely a structural foundation that contributes only about 30%. Let's start by tackling a huge industry myth. There's a common assumption that if you compose a panel with one model per family, say, combining a Llama, a Qwen, and a Gemma, you automatically guarantee conversational diversity. But this is a flawed context. This heuristic comes from offline evaluations where LLMs simply rate static text in isolation and tend to prefer their own family's outputs. The reality is that models don't stand alone, they interact. While the lab isolates models for scoring, real deployed systems rely on interactive deliberation. This involves dynamic debate, agentic workflows, feedback loops, and live adaptation. We have falsely assumed the family label holds up under live interaction. To understand this better, we need to unbox the family label. The takeaway here is that model family is really just an implementation detail bundling for entirely distinct variables. These are parameter scale, base architecture, the post-training recipe, like SFT, DPO, RLVR, or distillation, and runtime configurations, like think on versus think off. The big question is, which of these actually dictates behavior? To find out, we built the 2.5 million chain stress test. Our methodology involved constructing a massive two-agent forum corpus comparing exact conversational seeds across strictly controlled model pairs. Across 11 checkpoints, a seed post went to a first responder, then to a second responder, allowing us to measure the partner-conditioned response at a massive scale. We evaluated these interactions using what we call the surface Q diagnostic. Hedging serves as our validated headline metric, while conversational challenges and repairs are retained as exploratory checks. As you can see in this sample dialog, this diagnostic allows us to achieve substantial agreement, with a kappa score of 0.70. But there was a problem. Reasoning models tend to emit highly hedged internal thoughts before they actually speak, which unfairly skews the data against non-reasoning models. To fix this, we introduced the final paragraph instrument. We ignore the chain of thought preamble and parse only the final delivered conclusion, because that is the only part the other agents actually see. Next, we systematically isolated the variables. Our goal was to hold specific axes fixed and vary others so we could pinpoint exactly what drives conversational diversity. We tested scale, runtime, recipe, and cross-family swaps using a canonical 4 subset. The results were eye-opening. Cross-family swaps barely moved the needle. Looking at the canonical 4 subset of Qwen, Llama, Gemma, and DeepSeek, we found that swapping brand names provides minimal conversational diversity when models share similar training archetypes. The maximum variation was a mere 6.5%. So, if families don't drive diversity, what does? The post-training recipe. When we changed the recipe on a same base factorial, it created massive variance, an 18.22% shift in hedging depending on the partner's recipe. That is nearly triple the impact of swapping entire model families. This brings us to a fascinating core finding: LLMs don't have static personas. They dynamically adapt their conversational posture based entirely on the training recipe of the agent they are talking to. For example, when an R1 distill model talks to a Tulu DPO partner versus an R1 distill partner, it adopts a totally different posture and hedging rate, despite having the exact same model weights. In short, we have been optimizing for the wrong variable. The label on the box is just an implementation detail, while the training algorithm inside dictates how the agent behaves in a live panel. Again, swapping recipes on the same base gives us an 18.22% maximum variation, vastly outperforming the 6.5% variation from swapping families. We also cannot ignore runtime configurations. Runtime toggles drastically shift behavior on models with 100% identical neural network weights. Whether it's a Qwen model with think-on versus think-off, or an Anthropic Sonnet model toggling extended thinking, runtime must be tracked as a primary behavioral lever, not a background setting. To be sure, we validated this across frontier APIs. Smaller-scale factorials on closed API models confirmed our patterns. On the OpenAI API, moving between GPT-4o and o3 mini showed a roughly 7% hedging shift on the recipe axis. Similarly, Anthropic's Sonnet 4.6 showed distinct directional shifts when adjusting the runtime axis. So, what is the true metric of panel diversity? Our data shows that a panel of 3 Llama variants trained with different post-training recipes, including our one distill, is 7.5 times more conversationally diverse than a standard family diverse panel of Llama, Qwen, and Gemma. However, there is a crucial catch called the distillation dependency. If you replace the R1 distill model with a standard RLVR checkpoint, your panel diversity drops drastically, becoming 6 times worse than the baseline. Without reasoning distillation, recipe mixing just leads to conversational homogeneity. It is time for a new blueprint for panel composition. We need to stop tracking model families and start tracking the architecture of behavior. The old way focused on brand names and led to surface homogeneity. The new way focuses on the base, recipe, and runtime, such as combining SFT, DPO, and R1 distill, resulting in high conversational heterogeneity. Finally, I want to leave you with the architect's diagnostic checklist. First, treat the recipe as a primary slot by designing panels with distinct training algorithms. Second, explicitly track runtime configs, never just log a model's name without noting if think is on or off. And third, stop relying on the brand name. Model family alone is an incomplete and misleading proxy for conversational diversity. Thank you for watching.